My name is Skyler Welch, and the company I created for this project is named Lance Machining. So, a little bit about me. I'm a senior at Grandview, obviously. I've been in the tech pathway for a while. I've been doing CCIC as well, doing all the manufacturing, advanced manufacturing kind of stuff over there. I will be attending Metropolitan State University in next semester fall. And I really like machining. So, I wanted to make a project where I could really use it after I was done. And something that inspired me is the 3D printers that I have at home and the routers at CCIC. So I've been using the routers at CCIC for a while, and I was like, this is expensive. Why not make it cheaper and build it myself? So, with a little bit of time and a lot of frustration at my computer, I was able to put together some stuff, but I wouldn't spend too much money. It's still a lot of money for like a one-off project if I was going to make it a one-off project. I soon realized that that was not the case. I was hoping to get, at the start, $700–800. I was hoping to have a reasonable build plate, 4x4 feet. Pretty big for a hobby CNC. I didn't want to have too much run out because then it's kind of useless, and I wanted to be able to cut some really nice materials like aluminum. I don't have the picture. There's that half assembled. So the end result, it moved in 3-axis. I'm not going to make a 4-axis or a 5-axis until I get a few more parts and a few more $1,000s to spend. But it is now 6.5 by 6.5 feet. The total price was $2,332 to the state. That's without buying a wood plate for it. And I can't really do any motor testing, but I know that all of it works because I've seen systems run and I've tested them individually. I can't really test the accuracy of the machine itself. My company logo design. So I was thinking a while ago, and I was like, well, I made a company logo design in Ms. Lujan's class last year, 2 years ago, business class. And I was thinking, well, why don't I just reuse the same one? Except I had to modify it a little bit, make sure it fit the memo. So I have Lance Machining. The Lance is a drill bit, because I'm doing a lot of machining. And then the colors are supposed to represent professionalism for blue, and then BL is supposed to be caution and ingenuity. And basically, I wanted to make a emblem of the company to make it like really show what I was trying to do, but not make it too overcomplicated. So my 5 objectives, very generally, I wanted to have like a better skill set, and I wanted to have a cool tool out of it. As you can see here, I'm trying to remain cost effective. That didn't work out, kinda. I did improve my electrical capabilities quite a bit, and I have not gotten to apply code to my CNC machine yet. I will do that later this summer. My advisory committee, I have Mr. Gabriel Rosaire from CCIC and Mr. Paul Clinton from CCIC. They're both instructors there in the manufacturing pathway. They were helping me with various things like how should I build the machine to make it more stable? What would be the best kind of code to use for a CNC machine so it can run off SolidWorks? As far as that goes, my support advisors are my grandpa and my mom. My grandpa is coming in with the financial support, which I'll have to pay him back in full later. And then my mom was trying to keep me on track, just make sure I didn't get like sidetracked in like details doing one thing or just not doing anything at all. So the initial project timeline was pretty reasonable for as far as like what my starting objectives were, making a small CNC machine. I was trying to really get at it that I was wanting to get the SolidWorks model, the assembly, all the data on there in sheets and not just have like the part number written down. So I was trying to spend a lot more time doing SolidWorks and researching, and then in the very first part, and then build it, and then do SolidWorks and researching after I finish the build. Here's how it worked out. The electrical was pretty crazy. There was a lot of crooks and turns over there, so I had to do a whole lot of like investigating the house's wiring, figuring out how much a house's outlet supplied. That was pretty easy, and then figuring out how much our breaker supplied. If our gauge of wires inside the house could run the machine without melting in the walls. A lot of that. So it really turned into a big research project and a little bit of assembly and cutting. My research began on styles of routers. You can have multiple styles of routers. You can have it like mainly like 3D printers, and then there's gantries. You can have your router's bed move, that's more of a mill, and you can have like different ways that the material clamps into. So what I was trying to do was more research on making it more efficient, and then I did not enough research on how many electronics I need. Mistake. So my biggest roadblocks, a big one was the spindle, because the spindle I was using was decently expensive, about a graphics card, and it was a manual change. This means you have to go in, change the tool out when you're going in. You could have to do that 4 to 5 times in a complex part run. Doing that, there was a lot of restrictions on what kind of electricity I could use and what kind of cooling systems I could use. It had to be light, so it wouldn't crumble the frame. And then it also had to have the right type of collet size, so I could put the right type of drill bit in. It took a while. Other than that, I had a lot of electrical issues. So, like I mentioned, the house, I had a lot of issues finding parts to match the programming. So then I'd have to use Mach 3, which I finally settled on. And then I had a parts package for that. So I went out, found the parts, got the parts that worked with Mach 3, and then threw them together. My designs and iterations. A lot of the final parts, there's a little bit of variance with buying parts and then not having the design and then designing it yourself and then taking it into SolidWorks and then combining it with other things that you designed earlier. So I had to do a lot of 3D printing to test if the frames worked and if the profile of everything worked, so it matched up and all the holes lined up. And then another big thing I was doing was, once that all worked, I had to do a lot of building it, testing it, and then breaking it back down to fix one little thing. So all in all, that took a good 3 or 4 weeks maybe. Where I am with the project, the CNC router it's pretty structurally sound because I'm not running anything super heavy on it. It will cut decent materials, so the spindle I have is rated to cut up to aluminum, maybe steel, we'll have to see. And then I have all the files to build off whatever I want. So I can make this router bigger, smaller, I could add more features to it. Where I'm going with the project, this is what I'm really excited about. So because I've had my little test run, my research project, and it's going into the summer, I now have a platform to test all my ideas off of, and I'm going to be doing a lot of making little like upgrades, like limit switches to tell my machine where it is, so I can make it like more accurate. I need to decrease chattering if there is any, and then I also need to make sure that the code goes with the machine with the 2 motors, because I have a dual drive system. Other than that, it's a really short presentation. Other than that, here is a third, maybe, of the research I did. Questions?
For your actual router, can you just use a handheld router and then just put it on a belt system, or do you have to actually buy a router that's meant for milling?
I can buy a handheld router, but then I'm not super limited on tools, but then I'm limited on like what shut-off systems I use, and then e-stops, and then how I have to I have to integrate logic into the systems I'm using, and it's really hard to do unless I'm using like servos to control the router, or I'm using like power on-offs. Buying it all in one package is just a way of making sure I don't mess up anything in that process.
Well, how was the gantry designed?
So the gantry is 2 1/4-inch aluminum plates sandwiched together on either side of the router, and that supports the entire beam. And then the gantry is 85.5 inches, which goes across with eight bolts going on either side connecting it.
Why did you decide to make the
So one of the issues when I was looking at like how expensive parts were is that the increase in price from a part that was like 4 feet to 6.5 feet. So they measure in millimeters for most standard mechanical applications. 2,000 millimeters is way easier to get than like very custom smaller bits, unless you're doing like 3D printing sizes. So by making it bigger, I was actually able to decrease the time that I'd have to spend upgrading it later, but I also decreased the money I spent on the overall project.
So if you go forward and make this into a company, what would you say your price point would be for this router?
I wasn't actually planning on selling the actual router. I would sell the router designs, but it was more of like a part shop, build your own. Like you send me a design, I'll design it, and then cut it out for you kind of deal. So I guess that'd depend on the material and the size.
Yeah, is this something that you can just plug into the wall, or do you need like some other kind of generator or something to power it?
So that depends on the house. Older houses will not allow you to do it. Your walls and the wires in the walls will melt and you'll have flame. So what I am going to do is plug it to a 25 amp generator, and that will power the entire thing. But that's for like shorter use, and then later I'm going to get like a place where I can actually use it, or get an electrician to come out, but their quotes are very expensive.
Yeah. All right. Good. Well,